Hello, differential equation students, and welcome back to Unit 3. Okay, this is 7.2, and last time I taught how to transform things using LaPlace transformations, and now we're going to work on inverse transformations, and then the transformations of some derivatives. Okay, now here's the thing: we're going to want to create these algebraic equations. Okay. And once we do that, we're going to mess around for a while, but then we got to undo them, right? We got to solve them, which of course is the inverse. All right, so that's the premise. Now, we'll just start out right away here with a question. Okay, and again, I couldn't do like a goofy L here, but this is the Laplace transformation. And it's inverse because it's to the negative first there of f of t. Sometimes we don't have everything we need. Thus, we'll need to create it. Okay, this is very similar to what we did with u substitution when calculating antiderivatives. Things with like u substitution that you've done. If you had 2x, u equal 2x, then when you did du, you got 2 dx, right? And then what you did was, if you had a regular old dx inside your integral, when you put du in, you put 1/2 du equals dx. And then you could take this, and then you could plug it in, right? You did that stuff. We've done that stuff before. Okay, so that's what I mean by we'll have to fill in some missing gaps. And now what I want to do is I want to attempt to kind of tackle our very first one. We want to find the inverse Laplace transform of 7 over s cubed. So I'm really looking at 7 over s to the third. Well, here, this is where we'd want to think about, well, what do I know? Well, I know this s cubed, right? This s cubed should be with a 2 factorial over s cubed. That's what I know. I know if it looks like that, then the Laplace transform of that was t squared. Right? I know that. So I don't quite have this. Okay? I don't quite have that because I don't have this 2 factorial sitting up there. Right? I don't have the 2 factorial sitting up top. Now, could we create the 2 factorial sitting up top? Well, how could I do that? I could. Now, this is the original one right here, right? This is what I had. So what could I do to that thing to get it to look like 2 factorial? Well, if I did 2 factorial over 2 factorial times what I had over here, right? So then that's times 7 over s cubed. That would look, I could make this thing, like I can manipulate the way this looks. I can easily manipulate, I can put this over this. So it'd be 7 over 2 factorial times 2 factorial over s cubed, right? Easily do that. The reason that that's very helpful, right? If I try to break this down slowly here, this thing is this. Okay? Now, as I'm thinking about it, oh, okay, so I know that the Laplace transform is this, but I'm taking the inverse. Well, going backwards, that would mean that this thing that I just boxed in blue there, that would be t squared, right? I'm going backwards. Well, okay, what would be left? Well, this is the constant here, right? So the constant gets pulled out, which means I just have to stack it on times it. Okay, so then I would have that there. Of course, we could do a little bit of manipulation here, and we could say this is 7 over 2 t squared, and that is the inverse. Okay. So that's only your first one, right? We're gonna try to do this again. So let's try a little bit bigger problem here. Here I have the inverse Laplace of this bigger one, right? So here when I write it out, maybe I'll try to break it down first. This would be 9 over s to the 4th, s to the 5th, minus 6s squared over s to the 5th, plus 8s over s to the 5th, plus 11 over s to the 5th. Okay, and then, okay, furthermore, if I tried to break this down even more, it'd be 9 times 1 over s minus 6 times 1 over s cubed. And then what would I have? Plus 8 over, or times 1 over s to the 4th, plus 11 times 1 over s to the 5th. What I want you to do when you do this is now you should start like ignoring the constants and just focus here. Is this missing anything to convert backwards? I know the Laplace transform of 1 is 1 over s. Oh, so the inverse Laplace of 1 over s has to be 1. So then down here, I know that this thing is just 9 times 1. Now I keep going, right? I keep going. Like this one here, what would this be missing? Well, here I know that s cubed. Well, I'm used to seeing 2 factorial over s cubed. It doesn't have the 2 factorial up top. Like I would need a 2 factorial up top. That is way too thick. Okay, 2 factorial up top. But if I do that, we know this from way back in our days, right? We'd have to also divide by that. Right? We'd also have to divide by that. So we draw it in kind of like that, which, all right, this one sits up top. So it's like these are pieced together. And I know that the inverse of that would just be t squared. Oh, and then I have minus 6 over the other 2 factorial. Then I just keep going, right? I got plus, okay, this 8. Again, here, what am I missing? Well, I would be missing, this is 4, so I need a 3 factorial up top. I would need it also on the bottom then. Then I would put this one over here with this, which would leave 8 over 3 factorial, and then s 1 over, or 3 factorial over s, 3 factorial over s to the 4th. The inverse of that, well, that was just t cubed. And I'm just I'm continuing this idea. Okay, what would this one be missing? Well, I need a 4 factorial. Oh, well, if I put it there, it also has to go down to the bottom. Oh, so this is plus 11, 4 factorial. This thing here becomes the t to the 4th. And it would be nice if we could simplify this just a little bit, right? I don't have to do a ton of work here. This would be a 9. 6 over 2 would be minus 3t squared. 8 over 3 would be, what, 4 over 3, because that's 8 over 6 t cubed. And then I have 11 over 4 factorial. Well, 4 factorial is 24. And, oh, I don't want that to be a 5. I want it to be 4. And there's my inverse of this thing. Okay. All right, let's try it again. Here, we break it down first. Okay. I see this. Please do not think that this is true. I mean, just completely incorrect, right? I mean, I would hope you'd never do that to me. There's no way that that's right. Okay, that's not how fractions work, not even close. So we can't be breaking it down like that. Instead, we would need to break this as 8s over s squared plus 9 plus 13 over s squared plus 9. Okay. Here, this one gets tricky. We haven't done a whole lot so far with these transforms, so it's tough to like have them completely memorized and everything. But when I have an s up top and then an s squared on the bottom, I instantly think cosine. When I see a number up top and then s squared on the bottom, okay, plus something, I'm instantly thinking sine. So I think that this one here is going to be some type of cosine. Well, I know that it's always like the square root of this 9 is whatever the cosine 3, whatever it's supposed to be. So in this case, like 3t. Right? I know that. But the problem here, okay, is should this 8 be up here with the s? If we look back, right, if we look back at our tables, the cosine one I still have circled here, that's s over s squared plus a squared. There's no number up here. There isn't a single number up there with that s, which means this 8 would have to be isolated out of it, right? I just care about this. That would become this thing down here. The 8 would have to get dropped down out front. All right, then looking at the next one, right? We're thinking here with sine. Well, sine, that was sine, same type of thing. The square root of that is 3t. I know that's going to be true, but up top, I should have also had that 3. I don't see the 3 up top. I see 13. If I want it to be a 3 up top, I would have to also divide by 3. And this is where I think I'll take a second here to take this over here to the side and show you what I mean. Okay, let me get even rid of this 3 here. What I'm saying is I take this 13. It's 13 times 1 over s squared plus 9. I don't want it to be a 1 up there. I need it to be a 3. If I put a 3 up there, I have to put a 3 down here. Now, this thing here is that, which means this 13 over 3 is going to have to get dropped down out front. Plus sign here drops, and I have it. Okay, so the inverse Laplace would be 8 cosine of 3t plus 13 thirds sine of 3t. Okay, so you're going to need that table with you dang near at all times. Okay, so here I'd like to try another one. And last time I told you to make sure that you reviewed partial fractions, and you're about to see why you really needed to review that. Okay, this thing is going to need to get broken. The problem is this bottom. This bottom, okay, has a couple binomials, right? A couple binomials, and one of them is even squared. And this runs in, or makes us run into a lot of problems trying to split them up and do inverses because we don't see a ton of these. Okay, we need to break this as a over s plus 4 for this one here. Then it needs to get broken as plus b over s minus 3. And finally, this is the one that you don't usually do in pre-calc, I don't think a ton. You see it's squared there, so I actually have to have c over s minus 3 squared. Okay, it is my job now to figure out what a, b, and c are. Okay, what a, b, and c are. In order to do this, okay, here this s to the 4th, right, I would have this top side. So maybe here I'll start at this. I have my top right here. This top is s squared plus 2s plus 9. Now it should equal then, if I'm splitting out the bottom perfectly, right, then it should equal the tops. Now the problem with the tops though is here, if I were going to combine this a, if I was going to make this a back, if I was going to take this whole thing here and put it back over here together, I would have to get a common denominator between all of these. What would the a, this term here, what would it be missing? Well, a would be missing s minus 3 squared. It would be missing both those. Okay, well, and then I just continue this logic, right? Here, what would be, if I'm going to try to put it back over this way, I would need a common denominator. Well, b, what is it missing? Well, it would be missing s plus 4 from this term over here, and also this one's squared, so it would also be missing one of the s minus 3's. Okay, and now, you know, you just keep going with this logic here. This first time, I'll try to go a little slower. Again, if I'm thinking about putting it back over here, what would c be missing? Well, c is missing the s plus 4. Now I have this auxiliary equation set up. And here is where we have to start lining up. We have to start lining up things, such as, here when I distribute, right, like, first time, let's just do this. This would be a times s squared minus 6s plus 9. Plus, let's see here, b times s squared plus s minus 12. Plus c times s plus 4. Okay? And I have s squared plus 2s plus 9. Now when you're doing this, okay, I am going to match. I'm running out of color, so I apologize if I have to reuse some other ones. Here, this s squared, right, has a 1 sitting out here. So for the s squareds, 1 should equal, well, I have an a, because it's times this s, plus b, because it also has an s squared. There is no s squared over here for c, so this is a small, tiny auxiliary equation right here. There's my s squared. Next, I would just continue to move, right? Let me see if I can conjure up another color here. Next, I see this 2s. Okay, so for the s's, I should have 2 equals, now what over here would give me s's? Well, this a times this negative 6s would give me a negative 6a. Again, you're removing the s's because this is the s equation. Here I would have, the next I'd have b times s. Okay, so that's plus b. Then I have c times s, so that's plus c. And now I've created another little tiny auxiliary equation, right? Another one. And finally, can I get one more color here? I see the 9 there. Okay, this is for my constants. That's a 9 equals, okay, well, what would have this would be a times 9. Oh, okay, so that's 9a. B times negative 12, that's negative 12b. And c times 4, that's plus 4c. Okay, so here, the first time that we solve one of these, what I'm going to do, okay, what I'm going to do is we're going to do this old school just to kind of refresh your memory. This is a 3x3 system of equations. Okay, I'm going to use this thing to solve it. So all the way back, algebra 2 style here, this would be equal to this top one here. I could use that to give me 1 minus a equals b. Then I can take that and I can plug it in to the others. So if I did that, right, if I took that and I plugged it in, I would have 2 equals negative 6a plus 1 minus a plus c. And my other one is I would have, what, 9 equals 9a minus 12 times 1 minus a plus 4c. Okay, well, we do a little bit of math now, right? We gotta do some math here. This would be negative 6a. That's another one, so I'd have 2 equals negative 7a plus 1 plus c. Well, then that's 1 equals negative 7a plus c. That was from my top equation. My other one here, I would have, I'll try to work backwards here. So I'd have a negative 12 times 1, that'd be a negative 12. I'll add it to the other side, so that's 21 equals 9a minus, oh, it's negative negative, so that'd be plus 12a plus 4c, which would then create 21 equals 21a plus 4c. And then in here now, we have a 2x2 system. which you've solved this thing before, right? You've solved a 2 by 2 system before. What would you do? Well, this equation here yields 1 plus 7a equals c, which then means I have 21 equals 21a plus 4 times 1 plus 7a. Well, this would make a 4. Subtract, I would have 17 equals 21a plus 28a. 21 and 28 make 49. Divide, and I get 17 over 49 equals a. And now we're unraveling, right? Which implies that 1 plus 7 times 17 over 49 equals my c, which would be what? 1 plus 7's cancel, so that's 17 sevenths, which means that c would be equal to 24 sevenths. And working it back through, I know that 1 minus a equals b. Well, that's 1 minus 17 49ths, which would equal what? That's 24 sevenths after I, yeah, I feel pretty good. After I, no, that's not right. I don't feel very good about that. Let's see here. 24, yeah, this thing right here is right. So it's 1 minus 17. 17/49, well, that's what? That's 32 I would need. So this is 32/49 equals my b. So I have b, I have c, and I have a. Now the problem is, where are they? Like, this is a ton of work, right? But remember what the point here was. That was right up here to find what A, B, and C have to be. Okay? This next part is going to be really upsetting here, so I hope you have it all written down, because I'm going to erase this part here. Now, I got some space, so I can actually fill this thing in. What was A? Well, A was 17/49. So what I'll do is I'll write 17/49 times 1 over s plus 4. B comes next, right? What was B? B was 32/49. So I have plus 32/49 times 1 over s minus 3. And finally, C was 24 sevenths plus 24 sevenths times 1 over s minus 3 squared, right? Now's a great time. Pause the video, make sure you're understanding how I got there, right? We're splitting this up, right? And if I split this up now, I think that this looks, or I'm at least hoping that you see this thing right here, and you say, hey, that looks really familiar. That's that e to the opposite. Okay, this is plus 4, so it's minus 4t. Oh, and I can't do anything. That's just a constant. It just comes out front. Okay, well, then we just keep moving, right? We keep moving down the list. So my next one, I would look at this. Oh, that's the same thing. That's e to the 3t. Great. Well, what do I put out front? Well, that's the 32/49 plus sign. Finally, we get to this portion over here. Now, this one here, we've done this before. We did this last class. This is, okay, imagine that this was a variable. Well, something squared. Oh, that's when you added 1, so it's just a t. Now, you can't just ignore this minus 3. That's also the e to the 3t. And what's its power, or its constant out front, its coefficient? That's 24/7, and it's a plus sign. And we have found the inverse transformation. Okay. There is a slightly shorter way to do that, and hopefully I'll tackle that on our next one here. Okay. All right, so if I get myself some space here, let's just drag this down. You can see that I'm dragging this down. We'll see if I actually end up conquering that proof idea there. Might just leave that for extra credit here. Okay, so we're going to try this one out. And, I think I'm going to set it up kind of the same way I did before. This is equal to A over the S minus 7. I think that's decently clear. And then the next one here, this one's trickier, of course. You see how the S is squared inside the binomial? And we also have the trinomial sitting up top. That doesn't necessarily freak us out up here. But because this is an S squared plus 4 versus the whole binomial squared, this actually should have been hit in pre-calc. This is a BS plus C. Okay, and the reason that it's BS here is because of this S squared. All right, so this is the setup, right? This is the setup that we need. The next thing that we're going to need to do is we set up like the auxiliary equation, which I really enjoy doing. You take this 3S squared plus S plus 1 equals, it's A times whatever it's missing. Well, it has S minus 7. If we're going to make a common denominator, it'd be S squared plus 4. Right? And then we just keep moving. Then I have this BS plus C. It's a binomial there, so put it in parentheses. And then what is it missing? Well, it's missing the S minus 7. Okay, this one looks much simpler. At least looks it. Okay, at the start here. Now, once I go down through, now I'm going to start trying to tackle this auxiliary equation. Rather than set up the other ones here, we're going to implement this kind of like, hopefully there's a trick that'll help us out a little bit. Okay. Here, it would be really nice if I didn't have to deal with this B and this C, because they're two variables out of the three. What can I plug in for S right here that would get rid of all of these? Well, what makes this 0? Well, 7 does, right? So if I plugged a 7 in here, right, that would make this thing 0. Oh, well, then that makes this 7. Again, it's not going to matter because it's 0 times this. But over here, I would have A times 49 plus 4, because I plugged in 7 now, which equals, well, we were plugging in 7, got to plug it in over here. That's 3 times 49 plus 7 plus 1. And now we're going to do that math, which I don't think is overly difficult here. This is what, 155 equals 53A? Well, then that means that A is equal to 53 over 155. Oh, I'm sorry, I wrote that backwards. Sorry. Don't be mad at me. Okay, let me get rid of these thick blue lines anyway. We have 155 equals 53A, so A is equal to 155 over 53. Okay, that seemed super simple, right? That was pretty simple. And all because we used our logic to get rid of B and C here. Excuse me. Next, it'd be really great if I could somehow think of a way to maybe get rid of like this A here. Like maybe I could do that. Maybe there's some way I can figure out how to do that. Let's see, what would make this part 0? Well, maybe I can't because it's S squared. So even if I put a 2 in there, I'd make a 4. Right? I'm running into problems there to get rid of it. What we can do is here, could I get rid of this B? Well, if I let S, just this S, if I let it be 0, right, this would go away. Now this wouldn't, but this would, right? Or I'm sorry, this right here, this B would go away. So here I'll let S equal 0. If S equals 0, 0, 0, I would have a 1 equals 4A. This is gone. I have C times negative 7, so that's negative 7C. right? Oh, I already know that A is 155 over 53. And then I just got to solve this thing through. Of course, but I can divide, or I have to add that. Yikes. So it'd be 1 minus 455. I might actually need a calculator this time. I want to make sure that I, do this math here correct. I don't want to mess up just because of some small math. So here, we would take, let's make sure I can even see it. Where's it at now? I take 1 minus 4 times 155, 53, okay, and that would equal negative 7c. So 4 times 155 over 53. And I was taking 1 minus that answer, and then I would have to divide by negative 7. Of course, this is a decimal, right? We have this decimal here, and I'm pretty sure that everybody in this class knows that you can actually convert that to a fraction, which I got to be 81/53. Okay, so I have my A, I have my C. Now the only thing left I need to find is my B, right? And if I want to find the B, well, I know for sure that this A, right, doesn't contain any S's. There's no S's in here, right? The B has an S squared, okay, but it also has a just regular old S, right? That'd be a negative 7 BS. And the C would also have an S. That means that it has to be equal to just this S over here, which of course means it's 1 equals negative 7B plus C. Okay, we know C already, that's 81/53. So this is 1 minus 81/53, okay, equals negative 7B. Well, that would be 53 over 53 minus 81 over 53, which would make what I think that's 28/53 negative equals negative 7b. And I would divide by negative 7, and if I divide over here, that's a negative, or that would be 4 over 53 for b. And now I have my b, and my c, and my a, and this is a majority of the problem, right? This is the hard stuff here. Okay, we found those. All right, now would be a great time. Pause the video, go back, make sure you understand how I got them. Now I'm going to get rid of this. I'm going to try not to get rid of all the work I just did. All of it. I want my numbers, right? I need my numbers here. Oh. Seems that I'm struggling here with my board. Let me just rewrite it. So over here on the side, I would have C equals 81/53 and B equals 4/53. Okay. Now that I've done all that work, right? I've done all the hard work. Now I just got to replug this stuff in. So this A part, well, that's 155 over 53 times 1 over S minus 7. Then my B, Okay, now it's slightly trickier, right? But I can break this. So it's plus b, which is 4/53 times s over s squared plus 4, then plus c, which is 81/53. Okay, c, and then it's just times 1 over s squared plus 4. And now the hope is that we're getting into a rhythm where we can actually see that this thing here, that's just e to the 7t. And that's 155 over 53 out front. Then, okay? And then I have plus, okay, well, what would the next one be? Well, looking at it, this thing here, it looks exactly like the cosine one because of the s up top. So that's cosine of the square root of that, which is 2t. Now, oh, and then I just have my 4/53 sitting there, right? And finally, this one here looks really close to sine. The problem is this square root is 2, right? So I have sine of 2t, but this is supposed to have a 2 up here. Well, if I put a 2 up there, I also have to put one down here, which means that this 53 is no longer 53, that's 106, and I have an 81 there, okay? Of course, if it were to divide it out, we could divide out the 81. In this case, it doesn't simplify there, okay? And I just put my plus, and I have found the inverse of that one, okay? I'm not going to conduct this proof, okay? I'm not going to. I was thinking about it, but this video is already about 40 minutes long, and I really don't want it to be any longer. So instead, I think what I'm going to do is I'm going to pause the video, or I should say stop the video here. What we did on this video, okay, is we found inverse LaPlace transforms. On the next video, which you still have to watch, right? This is still all of 7.2. We're going to start with some basic derivative of the Laplace. And I might even mix in some equations. We might even just start solving some equations.